Hey folks, welcome back to Precalculus. We're going to continue on what we talked about with reference angles today as we talk about sine and cosine. Now I know that you've seen these things before. You saw them in terms of their graphs and the unit circle in Algebra 2 Trig, and you saw them in right triangle problems in geometry. My point of going over them again isn't to say that you don't know them. My point is to give you a deeper understanding and to set up that deeper understanding as a foundation for things that we're going to do later. So, without any further ado, let's get into it.
So we're going to talk about sine and cosine functions today. You've read the chapter. We're just going to clarify a few things. So a periodic function repeats at regular intervals. There's a pattern to it. It's not like the other functions where they kind of just go off on their own in one direction. Like once a parabola does one u, it's not going to do a second u. These are going to repeat. Now the cycle is the part of the graph, and this is referring to the actual graph of the function, from a point to the point where the graph starts repeating itself. We'll see an example on the next page. Now, the period isn't referring to the function, it's referring to the horizontal coordinates. So that's talking about the axis, the x-axis in most of our terms, or the u-axis. Let's take a look. So here we have a periodic function. We can tell it's periodic because from here down and back up, it's just going back, down, and up. And it's going to repeat the same pattern. So the cycle here is going to be dealing with the graph itself. So this is a graph of the cycle. I started at one place, I ended in the other. Now I don't have to start at the same place. For instance, this would also be a cycle. If I start here, it's also a same cycle. I can do the same thing here. I'm ending at the same place. Actually, this would continue to go up in here. Now, the period I'm going to do in blue. The period would be this. It's the horizontal value. And you can kind of think about it like time. Like how long does it take the cycle to last? Here's the period again. Here's the period again. Now, the interesting thing is, even though these cycles all started in different places, the green things all started in different places, the blue distances are the same thing, showing that the period is the same. So function f is a periodic function of x if and only if there's a number p for which f of x minus p is equal to f of x for all values of x in the domain. That's kind of a mouthful. So all it means is that there's some value here that I can subtract inside the parentheses, and it'll make this part equal to the original. And we know from our previous chapter that subtracting inside the parentheses is a horizontal translation. So I should be able to shift this periodic function over to, and this is subtraction, so I'm going to be able to shift it over to the right until it's able to completely overlap the original. Now, if p happens to be the smallest such number, we call it the period. And we're about to take a look at exactly that on GeoGebra. What we're going to show is that we have a periodic function, and up here, this a is going to represent the horizontal translation. So I'm going to turn this on, and we're going to see that every so often, the two graphs are going to overlap completely. And that's because the horizontal translation is pulling the red graph back onto the black graph. And you can see it's happening once, twice, 3 times, 4 times, about 5 times in 360 degrees. This goes up to 360 degrees. So I hope that was helpful. Now, here we have a slightly different definition of sine and cosine than you might have seen, but I promise it's related to SOHCAHTOA. Let u comma v be a point r units away from the origin. And the reason why it's r, by the way, is for radius. On the terminal side of a rotating ray. Well, the terminal side is the ending, and this is our ray. It's a ray because it keeps going on forever. So if we're in standard position to the ray, which means we're talking about this angle here, then sine of theta is going to be equal to v over r, And cosine of theta is equal to u over r. And this is something that you've seen before. It might not seem like it, but here, the v is equal to the height, so that's going to be this, and then r is the hypotenuse. Well, that means that sine v is equal to the height, the opposite side, over the hypotenuse. And that means that here, cosine of u, well, u is dealing with how far we are from the origin horizontally, so that's that. And it's the adjacent side over the hypotenuse. And we have a little demonstration to show what it's going to do with the graphs. So we're going to use that to help us find the graph of sine of theta and the graph of cosine of theta. And we're going to use some critical points here. We're going to start at 0 degrees. We're going to go to 90 degrees, 180 degrees, 270 degrees, and 360 degrees. And we're going to call this our max and that our min. So we know that if we're looking at this graph, sine is just the y value divided by the radius. So from 0 degrees to 90 degrees, this being 0 degrees, this being 90 degrees, my y value has only increased. So that means that here, it's going to go up, 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 and then reach its highest. That's representing the first portion. Past that, my y value is going to decrease, but still remain positive. It's going to be 0 at 180 degrees. Down, 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 down. My y value is then going to continue to decrease, but become negative, and it reaches its minimum at 270. Down, 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 down. Past that, my y value is going to be negative, but start increasing until it hits 0 at 360. Up, 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 boom. Sound effects included for free, folks. Why not? So that means that this whole thing is one cycle of my sine function, because it's how long it took us to get all the way around the circle. Now, it's a sketch. It's not meant to be the best in the world, and you'll see a slightly different shape when you graph it out on GeoGebra or Desmos. That's okay. Now let's take a look at how we do this with cosine. Now, with cosine, cosine is equal to u over r. And u is, that just sounds like bad grammar on my part. U is how far we are away from our origin horizontally. So, I'm going to start out at the same thing. This is going to be 0 degrees. And my u value here is at its max. I'm getting closer and closer and closer and closer and closer and closer. Now I'm at u equals 0, x equals 0. So that means here, I started and I just dropped down to 0. Well, as I go from here, my u value, my x value, gets more and more and more negative until it's at the most negative it's going to go, at 180. After that, my u value, my x value, is still going to be negative, but it's going to get less and less and less negative until it hits 0 again. And then last but not least, my x value, my u value here is positive until it reaches its maximum. So it looks like this. And that's the graph of cosine. It looks very, very similar to sine. The thing is, they start in different directions. And by knowing how sine and cosine are acting as you go around the circle, with those critical points at 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees, you can make transformations on the graph. So we're going to go over a couple of problems here. For 1 through 6, we're going to sketch the angle in standard position in a UV coordinate system. Then we're going to mark and find the measure of the reference angle. Find the sine or cosine of the angle and its reference angle, then explain the relationship between them. So let's do number 1. Well, I need my UV coordinate system. So I need the angle in standard position. Cool. So that's going to be 90. That's going to be 180. That's going to be about 250. This is my angle. Now, I need to find the measure of the reference angle. Well, my reference angle is going to be this. And we found the measure of the reference angle in the last class. Well, this is 250 degrees. The whole thing is 250. I got half a circle here, so I'm just going to subtract it. This reference angle is going to be 70 degrees. So find the sine or cosine of the angle and its reference angle. And then I want to explain the relationship between them. Well, sine of this is going to be over here. And in this quadrant, I'm going to have negative u, comma, negative v. Well, the reference angle is going to be up here at 70 degrees. And that's going to be at the point u, comma, v. So I'm going to have the same idea between them. The issue is going to, oh, that's an r. This length is an r. But sine of 250 degrees, by the way, writing it this way is the exact same as writing it this way. No parentheses. Well, that's just going to equal, since sine is negative v over r, and then if I were to write sine of the reference angle, 70 degrees, well, that's just going to be v over r, positive. So the relationship between them is one is going to be negative, one is going to be positive, but their magnitude, their actual, what number they're given, will be the same. The only difference will be the negative signs. Let's take a look at 2. By the way, I'm going to write sine of 250 is equal to negative v over r, and sine of 70 is equal to v over r. Just to keep that in mind for number 1. So for number 2, we're going to do something pretty similar. We're going to see something a little bit different, though. So 2, we're finding 320, so that's going to be 90, 180, 270, 320. The reference angle is going to be this, and that's going to be 40 degrees, because the 320 plus the 40 is going to equal to 360. And then if I find sine of 320 degrees, that's going to be negative v over r, because this is the point negative v over r. Negative u, comma, negative v. But its reference angle of 40 degrees up here is just going to be at u, comma, v, both positive. So sine of 40 is just going to be v over r. So we see something really similar here. We're getting the exact same values. The only difference is the sign. So for 7 through 14, we're going to use the definition of sine and cosine to write sine of theta and cosine of theta for angles whose terminal sides contain the given point and were given points. The first thing that I want to do is draw out a little diagram, label it with my point. So I'm going to do 7, 11. Cool. And this is my terminal ray. Now, theta is going to be this angle here. I don't know what that is. I'm not asked to find it. That's okay. I just want to find sine of that theta. Now, what I can do is realize that this makes a right triangle. The height of that is 11, because that's my y-coordinate. This is going to be 7, because that's going to be my x-coordinate. And what I can do is use the Pythagorean theorem to find what r, the radius, is going to be. So r is going to equal to 7 squared plus 11 squared, r squared. So that means r squared is going to be 49 plus 121. So that means r squared is going to be equal to, let's do this well. R squared is going to be equal to 170. And then I just take the square root of 170. You're going to need a bit of estimation here, that's all right. And the square root of 170 is about equal to 13.04. About 4. So I'm going to add it in, 13.04. So I want to find sine and cosine of this. I'm just going to give myself a bit more space. Well, sine is going to be equal to v, so 11, over r, so 13.04, sine of theta. And cosine of theta is equal to u, that here is the 7, over r, 13.04. So I found them. Gonna get these over and shrink them a little bit. Let's try 2. 4 comma 1. Well, 4 and 1. That's my terminal ray, which means that that's going to be a height of 1. That's going to be 4. And I can say r squared is equal to 4 squared plus 1 squared. R squared is equal to 16 plus 1, so 17. So that means r squared is about equal to 4 point some nonsense. I know, that was very, very exact of me. 4.12. You might be asking, but how do I know where to round to? I don't mind where you round to here, as long as you include a few good decimals, then you're good. So, sine of theta, and here theta is in standard position, so it's right in here. It's kind of scrunched. Well, that's just equal to v over r. Our v is 1, our r is 4.12. And cosine of theta is equal to u, so 4 over 4.12. And we've done it. So, last but not least, here, we're given the parent functions sine and cosine, and we're going to give the transformation of the parent function represented by the equation. So we're going to explain what happens, and then sketch a graph, a copy of the graph onto the figure. Clearly, you can't sketch onto your notebook, so you're just going to do what you can here. So, let's take a look at the first one. So, this one. Well, I covered right exactly where I needed to. Well, this really annoying symbol is just theta. The textbook kind of screwed it up. Not the textbook, but scanning it into the computer or whatnot. Well, we know what's happening inside the parentheses here is going to mean a horizontal translation. And we know that it's going to move everything 60 units to the right. So this is 60 degrees right. So that means the shape of this is going to stay the exact same, but it's just going to shift over. So I'm just going to pull this until it's shifted to the right. Now you might be wondering how far to shift it. Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 is going to be 360 degrees. And if 12 is going to be 360 degrees, each one of those is 30. So 1, 2. And that's what my graph would look like. I've shifted it over 60 degrees to the right. Now, let's take a look at 16. Well, 16, I'm adding 4 to my graph. I know, looking at this, that this is 4 units up. Okay, so I'm going to start with my normal graph. There's no dilation here, so I can do that. And I'm just going to shift it 4 units up. 1, 2, 3, 4. And that's what the graph would end up looking like.
Awesome. So you've seen where the graphs of sine and cosine come from. You've seen 3 different types of problems that are going to appear in your homework and dealing with it. You've seen how transformations that we covered in chapter 1 are also affecting the graphs of sine and cosine as well. So we're just building on the knowledge that we've seen, as well as adding in things like the UV coordinate system, adding in the unit circle, or at least circles that we've seen, and tacking on to knowledge that you already have from previous courses. Go give that homework a shot, and we'll see what happens. I'm always here for office hours if you need me, and you can stay on the Zoom chat if you need to talk. Good luck!